Okay, let's take a look at the two examples. I'm going to put some sound here to Ms. McCormick's video. The first example we're going to do is example 2A. That is a ray diagram. We'll start by drawing the first ray from the top of the object through the center of the lens, right where it intersects that axis, that optical axis through the center. The line will be perfectly straight. We're going to assume that it does not refract. The next line we're going to draw will be parallel to the optical axis from the point at the top of the object to the lens line. Then from the lens line, we're going to draw a line straight through the focal point on that side of the lens. You'll notice the two rays intersect at a point just past the focal point. We're going to draw a third ray from the top of the lens through the focal point on the same side as the object. We'll draw that to the lens line, and then we'll draw it parallel to the optical axis. And the three lines should intersect. We technically only need two of them, but the third one is good to check ourselves with. Where the three lines intersect, that's the position of our image. So we're going to draw our image right there. Since it came from the point, then we're going to draw from the optical axis to that intersection, and that will be the point of the image. Now we need to identify the type of image. It's a real image because it's formed by light rays and not sight lines. The image is inverted, and because the object is beyond 2 times the focal point on the left, the size of the image is smaller than the size of the object. Now you could measure the distance based on whatever scale your drawing is in, and that would give you the distance to the image. And here Ms. McCormick has approximated it as 22 centimeters. You could also calculate that from the numbers that were given in the problem in order to check yourself. The next example is example 1. We're going to do the calculation for the focal length. We start with the distance to the object is 8 centimeters. The distance to the image is 12 centimeters. And the question says find the focal length. So F is our unknown. The equation 1 over F is equal to 1 over distance to the object plus 1 over the distance to the image. We're going to solve for F. Actually, we'll first solve for 1 over F, and then we'll invert it to get F. So 1 over F is going to be equal to 1 over the distance to the object, that was the 8 centimeters, plus 1 over the distance to the image, 12 centimeters. That's equal to 1 over F. But first we need to find a common denominator. The common denominator of these two is 24. And we can get that by multiplying the first number by 3 and the second number by 2. And we come up with 3 over 24 plus 2 over 24. We can now add those together since they have a common denominator. And we get 5 over 24. 5 over 24 is 1 over F. So to get F, we want F over 1. So to get that, we switch these two around, flip them upside down, and we get 24 over 5 for the value for F. You can plug that into the calculator. 24 divided by 5, and we get 4.8 centimeters. Note that the units are the same as our given.